Okay, question number 11. Okay, so you've got two curves. You've got a higher one. The equation for that must be this, because that's the bucket down parabola. I can tell that because the coefficient of x squared is negative. Got your bucket up parabola. The equation for that must be that, because that's got a positive coefficient of x squared. So that's the bucket up one. And the curves meted A and B. Show that the coordinates of those are 1, 4 and 4, 7. That's simultaneous equations. Two different ways to work out y must give the same answer. So that way to work out y must give the same answer as that way to work out y. So 2x squared minus 10x plus 8 equals 0. Spot the common factor there. X squared minus 5x plus 4 equals 0. I think that factorizes nicely. So x equals 1 or x equals 4. If x equals 1, then I'm going to use this one, it's a bit simpler. 1 squared minus 4 times 1 is negative 3 plus 7, you get 4. And y equals 16 minus 16 plus 7. So there we go. The points of intersection are 1, 4 and 4, 7. Just like it asked me to show. Now, Roman numeral part 2. Points P and Q above each other, it says. I want an expression for that length. That's just subtraction, isn't it? If that was a height of 8 and that was a height of 3, you just go 8 minus 3. But how high is that? It's that height. How high is that height? How high is that? That height? Subtract them with a bracket to make sure it's clear that all of this is not being subtracted, not just what would immediately follow the minus sign. So what is that? Imagine multiplying out a it's not what Miss Fell's got. Oh, sorry, that's 4. 6 minus 1. Oh, sorry. What's going on here? Negative x plus 4 is 3. Ah. Oh, I've miscopied that. That's 6x. That's the x squared. So 6x plus 4x is 10x. Negative x squared, sorry about that. Divide everything by 2. Divide everything by negative 2, actually. Just makes it a bit simpler, quicker. Oh, I don't know why I'm saying it's equal to 0. There's no equal sign. That's terrible. It's just plain old this minus this. So it's 10x minus 2x squared minus 8x. So height of that is equal to this, which is equal to this, which is equal to this. Sorry about that. Now, use calculus to find the greatest length that could be. Well, when you graph something, most ones will have a highest point that's flat. So I'm going to try and find out where this is flat. So let's call that W. So I'm doing a graph of W versus X. So it could be this. Where is it flat? Well, let's do the derivative. Equals 10 minus 4x. So that's equal to 0 when x equals 2.5. Just solving that equation. but that's just when it's at its highest. The actual highest it can be is when you substitute 2.5 back into that. So the actual highest is 10 times 2.5 minus 2 times 5 over 2 squared minus 8. You pump that through a calculator and you get, thank you Ms. Fell, 9 over 2. Now, it didn't ask me to justify that that was a maximum, but I'm going to do that anyway, just to be sure. Quickest way is the second derivative, so that's negative, therefore max. So I can be confident that this genuinely is the maximum. The reason why that's important to check from time to time is that the maximum doesn't always come from a flat point. If it was bucket up, and I know that this isn't, then the maximum doesn't come from the flat point, it comes from these endpoints, which is why checks like this are always useful to do from time to time. Now, finally for question 11, we're going to find the area between the two curves. So, one way to do it is to find this area and then this area underneath that lower curve and then subtract, but there's a shortcut. Since you're going to be doing subtracting, why not subtract the algebra and then just work on that. Make sure you subtract the bottom algebra from the top algebra. We've actually already done that, but I rubbed it out. Over there it is. Thank you, Ms. Fell. And if you go all the way out to there, that's a 4. If you go over to there, that's a 1. So this is just good old-fashioned definite integration. So you place your curly with a square brackets and change the algebra to its primitive. In other words, whatever would differentiate that to become that, and normally you're supposed to put a 5 or a 7 or something, or a C, but you're not supposed to put a 5 or a 7, you're supposed to put a C to reflect the fact that that could be any constant, because any constant would disappear upon differentiation. But because of what you're going to do now, that would disappear anyway, so there's a convention that we never bother to do that. Don't write the algebra anymore, write these, substitute it in. Anyway, you pump that through a calculator and apparently you get 9 square units. So that's the answer to question 11, Roman numeral part 4. Okay, question number 12, distributive flower bulbs. It's a large number of tulip bulbs and daffodil bulbs, mixed in the ratio 1 to 3. Respectively. Respectively just means that you can infer something from the order. So if the tulips were mentioned before the daffodils, then the tulips must be the smaller one and the daffodils must be 3 times bigger. In other words, that order corresponds to that order. I'm just telling you what the word respectively means there, that's all. Now, this whole question 12 thing is about the binomial. That's a time saver for trees, because every time you pick bulbs, you can either go up or down. So that's tulip, daffodil, tulip, daffodil, tulip, daffodil. Imagine how awful it would be if you literally had to write this 10 times. In fact, this is so many. I'm just going to do a dot there. The reason why I recommend this is just to get you in the groove for understanding what the binomial does and to check for mistakes. That top section of the tree is literally 10 T's. That's when you pick 10. That will be when you pick 9 tulips and then a single daffodil, whereas this will be 10 daffodils. This is time well spent, I claim, because it just gets you completely clear on what you're doing and what these binomial coefficients are supposed to help you with. Just like you do for a simple GCSE tree, you just take all these probabilities and multiply them. So that would be a quarter to the power of 10, whereas that would be a quarter to the power of 9 times 3/4 to the power of 1, whereas that will be 3/4 to the power of 10. Okay, so I'm now ready to answer the question. Roman numeral part 1 for part A. Exactly 4 daffodil bulbs. So that's something like this. So 4 D's and 6 T's. So every time you see a D along here, you pick up a 3/4. So you do that 4 times. And every time you pick up a T, you pick up a quarter. But the point is that that's not the only element of the summary that's going to have that particular combination of 3/4 and 1/4. There's going to be loads of them because this tree is absolutely enormous. I think there's 2 to the power of 10 elements in this summary. It's absolutely enormous. It's not like the good old-fashioned probability trees from GCSE, which just have 4 things in the summary, you know, like heads, tails, tails, heads, and heads, heads. This is literally enormous. There's like 1,000 things down here. And there's going to be loads of them that pick up 3/4 4 times and 1/4 6 times. How many of them? That's what the binomial coefficient is for. Add them together, put that on top of a C. Faster way than adding them together is just remember how many of stages of forking you had. And then for down here, you can either use that or that. It really doesn't matter. You type that into a calculator and you get 0.0162 to 4 decimal places. And that's the answer for A part 1. What about A part 2? At least 1. Okay, I always recommend saying out loud what at least 1 means. At least 1 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could... So what was that again? That was at least 1 means 1, 2, 3... So there's a huge number of things from the summary that have at least 1 T in them. You could use the formula 9 times, just like I did there for 4 daffodils. I can now use the formula 9 times for all these possibilities for the number of tulips. But much quicker is to say that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tulips means not none. So I'm going to work out the probability of none, which is this guy, so 3/4 to the power of 10, and then subtract that from 1. So here's my answer here. It's 1 minus 3/4 to the power of 10. Which is 0.9437 to 4 decimal places. So that's Roman numeral part 2 for part A. Part B. This time we've got 2 boxes. So this is a good old-fashioned tree. First box, second box. Not quite sure it'll only have 2 forkings. Let's just see. Okay, total of 3. So how could you get 3? You could have... So what I'm doing here is writing the number of tulips. You could have 0, 1, first box you could have 0, 1, 2 or 3. In the second box you could have 0, 1, 2, 3, 0, 1, 2, 3. This is just enough to write out. Any more than this, I'd start just thinking instead of writing it. Here's the summary, just enough to write out in full. Any more than this, I would be trying to think it rather than writing it. Now, which of these add up to 3? That one, that one, that one, and that one. Now, to get these probabilities, I multiply what's on the branches. But note there's a repetition here. So instead of doing those, I'm just going to double the figures I get for these. Now what's the probability of no tulips? No tulips we already worked out before. That's entirely daffodils. And 3 tulips is 10C3 times, what's the probability of a tulip is a quarter. And what's the probability of 1 tulip? It's 10C1. What's the probability of a tulip? A quarter to the power of 1. Times 3/4 to the power of 9. What's the probability of 2 tulips? It's 10C2, a quarter to the power of 2, 3/4 to the power of 8. So what you type is this times this times this, plus this times this times this. Oh, what a beast of a question. And when you type that successfully, according to Miss Fell, you get that to 4 decimal places. What an absolute beast of a question. I don't know how I would have done that if I hadn't got my story straight by drawing out this tree, even though it was very time consuming to do so. Now, question 13. You got this hexagon. It's a regular hexagon. As usual, we name these things around the circle. Don't zigzag around like A, B, C, D or whatever. You just go A, B, C, D, E. F or A, B, C, D, E, F. Center is O, so that could lead to a whole bunch of equilateral triangles stuck together. Directly above the center, oh, so they're all 0.5. So right above is this point V. It goes down there. These drops here, which are called canes, 2.4 meters. And that's all I got. Now, here's what's special about the numbers strategy. The fact that these are equilateral triangles is highly significant because that means that that's 0.5 as well. So here's a red triangle, it's this guy. These things are chocker with right angle triangles, so you can use SOHCAHTOA. when you have a cuboid, by the way, every triangle you basically draw is right angle. The only way to get a non-right angle triangle is always to use diagonals, like that. Any other triangle that uses at least one edge will always be right angled, and therefore you can do SOHCAHTOA and Pythagoras on it. And sure enough, because you drop straight down to the bottom, this will be a right angle. So that's your 2.4, that's your 0.5. So what's that distance there? X squared plus 0.5 squared equals 2.4 squared. So x squared equals 2.4 squared minus 0.5 squared. So x equals the square root of 2.4 squared minus 0.5 squared. Pump that through a calculator, and you get 0.235 meters to 2 decimal places. So that's your part 1. The angle between each cane and the ground. Oh, I shouldn't have rubbed that out. 0.5, this is my red triangle. 0.5 and 2.4. So if I want that, so this is SOHCAHTOA, so cos alpha equals 0.5 over 2.4. Pump that through calculator, just go shift cos this. As long as your calculator has a little d up the top rather than an r, it'll give you the correct answer, which for us is 78.2 degrees to 3 centimeter figures. So that's that. And finally, the angle between the, so not finally, Roman numeral part 3, the angle between the plane VAB and the ground. So that's this and the ground. Now that's not the same as that angle there. What that is like this blue triangle here. So that blue triangle, if I copy that out separately, will still have a... oh, it'll have the height that I discovered in part 1, which is 2.35. So that I need to know what that, here's this little black triangle out here. I need to know what it is to cut across like that. Well, if that's 0.5, that's 0.25. Let's call that h. H squared plus 0.25 squared equals 0.5 squared. So h squared equals... so h equals the square root of 0.5 squared minus 0.25 squared. Sorry, that's off the screen. So that's that there. And we've been asked for this angle here. So tan of beta equals 2.35 over this. I'm just being lazy here to type it. So you go shift tan, do great big brackets, type that all in one go, and And that's your answer for beta in the blue triangle. Yep, so that's that. And finally, for Roman numeral part 4, the gardener stretches a horizontal wire around the structure to strengthen it. He fixes the wire to each cone at a point 1 metre vertically above the ground. So for example there. Or on the blue triangle there. I'm always doing that, ruining my blue pen by putting a black lid on it. So that'll be 1 there. Now, yeah, I'm pretty sure about that. Not quite sure what to do here. Just give that a pause. This is my blue triangle. So that's 2.4. That's... So I was being lazy before, I'll actually work out what that is. That's 2.5 squared. Sorry, that's square root of 0.5 squared minus 0.25 squared. So that's that. We have this being a 1. So I'll copy out, smaller triangle is this, bigger triangle is this, so therefore that divided by that has to be the same as that divided by that. So 2.4 equals so that divided by that equals that divided by that. So in other words, x equals square root of 3 over 4 divided by 2.4. Now I'm not completely sure why this would be useful. In other words, 5 root 3 over 48. I now think that maybe I shouldn't have used blue triangle, I should have used red triangle. Red triangle was this, remember? 0.5, 2.4, So that's where the y goes. That's a 1. So here's big triangle. Here's little triangle. That's a 1. That's an x. So 2.4 divided by 1. I'm going to delete this. 2.4 divided by 1 equals 0.5 divided by x. So therefore x equals 0.5 divided by 2.4, which is 5/24. So remember, that was little triangle. So that's 5/2.4. So that section there is 1 minus 5/2.4, which is 5/24, sorry, which is 19/24 there. Oh, I get it. Third time lucky. It's actually green triangle that's the best. I don't think that's completely wasted. So that's 0.5. That's 2.4. But that section there can be done with Pythagoras. That section there is W1 5/24. So W squared equals 1 squared plus 5/24 squared. So W equals the square root of 1 plus, in brackets, fraction 5/24, and the brackets square it. So W is root 601/24. So that is how far you need to go up red triangle to get to this point where the wire is. So that's also how far you have to go up green triangle. Okay, so classic advice for similar triangles is draw the triangles out separately. So there's big green has an 0.5 and a 2.4. Little green has a mystery, let's call that M, and that section would be 2.4 minus root 61/24. So that divided by that equals that divided by that. So therefore M equals that times 0.4. So therefore the length of the wire equals 6 times that. You pump that through a calculator and hopefully you get what Miss Fell got, which is 1.72. Okay, anyway, sorry it took me so long to do that. Okay, question number 14. looks like one of these linear programming things. So a company produces two liquids, X and Y, ingredients A and B in them. So I'm just going to copy out this table. So these are the ingredients. These are for the liquids. This liquid is made up of 4 centiliters of A and 2 centiliters of B. This liquid is made up of 3 centiliters of A and 5 centiliters of B. And there's a limit on use of A. It's 84, so this is the limit. And there's a limit on B. So if, let's call lowercase let's call lowercase x the number of bottles and lowercase y the number of bottles of type Y. So let's say that was 10 bottles, you'd take out 40 centiliters. Let's say that was 8 bottles, you'd take out 24. So the total would be 40 plus the 24. So if it's not 10 and 4, it's instead x and y, it'd be 4x plus 3y has got to be less than or equal to 84. So in fact that's what they've told us they've written down. The last sentence before the questions begin is, from this information analysis, an analyst writes down this. So therefore x and y must be number of bottles of x. Y is number of bottles of y. Now, everything I said prior to that was just me getting my head around the question, just doing what I normally do for these linear programming ones. Then it happens by chance that I actually answered Roman numeral part 1 in the course of that. Now, it's told us to write down another inequality. I'm just going to do the same thing there. So 2x plus 5y, it's got to be less than 90, and of course x is greater than 0 and y is greater than 0, so now it's going to be asking me to graph those. So now it's just like any other simple linear programming question. I'm going to graph that. But initially I'm going to graph that. Then I'm going to graph this. That'll be a region. But initially I'm going to just graph that to get a line. So here we go. Do that with a quick table. If y was 0, x would be 21. So I'm always saying you should do this properly with a ruler because the gradients matter for where your graze point is. So let's do this properly. They're 5 centimeter notches. Do some 5 centimeter notches on this as well. Now what do my notches mean? Well, what are my x-intercepts? For this one it's 21 and 45. So let's make that 40. So that would be, so 5 centimeters is 10 units. So 1 unit is half a centimeter. So my 21 is there. And my 45 is 2.5 centimeters beyond that. What about my y-intercepts? 84 divided by 3. So for the mental arithmetic, it's 28. So let's say same scale here. So 10 units is 5 centimeters. So I've got to be 2 units short of 30. So that's 28, because 84 divided by 3 is 28. So what did I say? 1 unit was half a centimeter, so I need to go 1 centimeter down, so that's 28. I'm going to write this one. 90 divided by 5 is 18, so that's again 1 centimeter short of that, so that's 18. So one graph goes from 21 to 28. So it's this. So that's black. On to the blue one. The other graph goes from 18 to 45. So we get that classic crisscross we often get. Right now, what side do we... So we want something that satisfies x greater than 0, so we want the right hand side of this. Y greater than 0, so we want the upper side of this. What side of the blue line do we want? Well, let's put this back in. And let's put that back in. Use a test point, 0, 0 as a classic. If you put a 0 there and a 0 there, do you get something less than 84? The answer is yes, so we want the underline, the underside of the black. If you put 0, 0 there, 2 times 0 plus 5 times 0 is certainly less than 90, so we like 0, 0, so we like the underside of the blue line. So therefore, we want this little region here. So we're supposed to shade what's not required. Okay, so that's question number 3. By the way, the reason why we ended up with this is because it's implied by the question that we want all 4 of them to be true. Therefore, so this section here is on the correct side of the black, but not on the correct side of the blue. If we need all 4 of them to be true, then any one of them being false knocks that region out. So this is good from the point of view of being above this. It's good from the point of being to the right of this. It's good from the point of view of being under the black, but because it's above the blue, it therefore gets cut. If we'd wanted to shade what satisfies this or this, it would have been completely different. This would have survived. Anything that would satisfy at least one inequality would be good. So I think almost all the diagram would be shaded, except I think, yeah, the only parts that would be shaded would be down. No, I think it'd be out here and up there. Almost everything would be shaded because when you use the word or, it gives you 4 chances to make it true. Anyway, that's by the by. Now get back to the question. Company needs to produce the same number of bottles of X and Y each day. Oh, right, so X equals Y. No, sorry, X equals Y. I think. What's the maximum number of bottles of X and Y that it can produce? Well, basically what it's saying is we have to be on this line. So if we have to be on this line, I should call this the green line, then the best you can be is as far out to the right as possible, because when you move out to the right, that's when you lift both X and lift both Y. So we need to be there. Now what is there? What is that? Well, to find that, solve simultaneously between X equals Y and the algebra for the black graph. This is why it's so crucial to be very careful with graphing these and getting all the units right, because if I had done this even slightly approximately, that maximum point would now be possibly intersecting with the blue line. It's crucial to know what algebra I now need to use. The black algebra was 4x plus 3y equals 84. Solve that simultaneously. There's a gift, y equals x. So 7x equals 84. 84 divided by 7, I think, is 12. So therefore y equals 12. So there's your most that you can make if you have to produce the same. Now, so that's Roman numeral part 4. Now, it now asks, what if on one day the company does not have to produce the same number, so in other words it doesn't have to be on the green. Write down the maximum number of bottles that can be produced. So in other words, what's the biggest that X plus Y can be? So this is like a standard linear programming question now. I'm just asking to maximize that. So I do this by just putting a sample little value in. Let's say X equals just something nice and big, 30. That would lead to this red grays line. Now, being super careful, you bring that down until it makes contact with the right region. So that's your grays point there. What is the coordinates of the grays point? The coordinates of the grays point come from solving the blue and the black algebra, which I'll now do. They're nicely lined up. So you double this line, do 3 subtractions, that minus that blank, that minus that 7y, that minus that 96. Is 96 divisible by 7? No, it's not. It's 13 and 5/7. So x therefore equals, so x is 84 minus 3y over 4x. So, oh damn, I lost it. 84 minus 3 times 13 and 5/7, all, sorry, that shouldn't be divided, all divided by 4. So that's 10 and 5/7. So the grace point there is 10 and 5/7, so a little bit past that, and a little bit under, a little bit above the 15 mark there, a little bit under the 15 mark, sorry. However, you can't have half a bottle, so you can't have part of a bottle, so but if you could, the maximum would be that plus that, because remember we're trying to maximize x plus y. So it'd be 24 and 3/7. So you certainly can't get to 25, so the maximum will be 24, but can you achieve that with whole number combinations? Well, sample whole number combinations are 10, 14, 11, 13, 12, 12, 9, 15, etc., etc. Do they actually obey the constraints? So that's my x and that's my y. Is 4 times that plus 3 times that less than 84? Yes, it is, for the black inequality. But is just replace that with what that used to be. That used to be 2x plus 5y is less than or equal to 90. So is 2 times 9 plus 5, is 18 plus 75 less than 90? No, it's not. So that fails the blue inequality. What about 4 times 10, that's 40, plus 3 times 14, so that's 42, that's 82. That passes the black inequality. Does it pass the blue inequality? 2 times 2x, so 2 times 10, that's 20, plus 5 times 14. That is 70, so that is 90, so that passes the blue inequality. What about 11? 4 times 11, 44 plus 39, that squeezes under 84, so that's good for the black. Does it squeeze under the 90? 22 plus 65, yeah, that's 87, so that's good for that. So I should tick that. 4 times 12 is 48. 48 plus 36 is 84, so that's good for the black. And what about 2 times 12? That's 24, plus 5 times 12, that's 60. That's 84, so that squeezes under 90, so that's good. So therefore these are all the combinations that work. I'm pretty sure 8, 16 won't work, because what I've done very carefully here is check whether those points are actually inside this white region. 8, 16 I'm thinking is now clearly not, because yeah, that's starting to be clearly there. But I mean I can check it if I want to. And so anyway, that's the answer to Roman numeral part 5. Oh, sorry, you couldn't see my ticks on the video there. I'll just make that clear. So this is just me endorsing each of these coordinates by checking it against the black inequality and the blue inequality.